Today I'm going to be evaluating an integral without using any fancy tricks. This is the integral we have, the integral from -1 to a half of root 1 minus x squared dx. And now you can evaluate this using a trigonometric substitution, but I'm not going to be doing that here. The way I'm going to be doing this is just by drawing a picture. What I want to do is first sketch the graph y equals root 1 minus x squared onto an xy plane. Okay, and you might ask, well, what does this look like? And this is actually just a semicircle. Why is it a semicircle? Well, let's rearrange this. Let's square both sides. So y squared is 1 minus x squared. And then adding the x squared on both sides, you get x squared plus y squared is 1. Okay, and now you might think, well, that's the equation of a circle with center 0, 0 and radius 1. However, these are these steps going from here to here, these are only one-way implications, which basically means they're not reversible because we squared. So what we have to do is remind ourselves that y is root 1 minus x squared. In particular, it's the square root of something. And now whenever you square root a number, the answer has to be non-negative. It cannot be negative. And so that tells us y is at least 0. So as opposed to drawing the kind of full circle, we're only going to look at the top half where the y values are non-negative. So we'll look at something like that. So there's 1, there's a half roughly, and there's -1. And this integral here, well, that's just the area underneath the graph from -1 to a half. So this area here, that's what we want to work out. Okay, well, how do we do that? The trick is to draw this line here. If I call this triangular area A, and then this big sector here, B, we're going to work out A and B separately. Okay, well, this hypotenuse is 1, and this length here is a half. So if I call this angle here between them theta, I can say that cos of theta is 1/2. And so that just means that theta must be pi over 3, or 60 degrees. Okay, great. How do we work out the area of the triangle from that? Well, we can just use a half AB sine C, or equally, you could try and work out the vertical length there and just do half base times height. I'm just going to be using a half times 1 times a half times sine of pi by 3. A half, that's quarter. The sine of pi by 3 is root 3 over 2. So that's going to give us root 3 over 8. So that is the value of A. Okay, cool. What about the value of B? So this area here. Well, if theta is pi by 3, that means that angle there must be 2 pi by 3. And so the area of B, we can just use a half times r squared times theta. So a half r squared. Well, probably shouldn't use theta here. I'll call it phi. So half r squared phi, which is a half, times 1 squared times the angle, which is 2 pi by 3. And that's going to be pi by 3. And so therefore, this integral up here is simply equal to pi over 3 plus root 3 over 8.